For this question number 1, it's a calculator based multiple choice questions. It says a graphing calculator is required for some problems. So the first question says if it's at x equal 3, this piecewise function is defined, undefined, continuous, and differentiable. So technically we are looking for continuity, differentiability, and if it's defined or not defined. So for the continuity, we know we have 3 conditions. Differentiability, we have to take a derivative of the we have to take a limit of the derivative. So I'm writing on top of these words, that's what it means. So continuity, the first condition said, and it's multiple choice, so but we still have to solve the problem on the scratch paper to see what the answer is. Continuity, is it defined? So I'm going to use this function for define because that's where the equal says. So I have 6 times 3 minus 9. It's going to give me 6 times 3 is 18. 18 subtract 9 is 9. So yes, it is defined because I'm getting some y value. Question number 2, condition number 2 said limit x approaches 3 from the left. Left is x squared. So I'm using x squared and I'm going to plug in that 3 there, which is going to give me 9 again from the left. Then I have a limit x approaches 3 from the right. And from the right, I'm using 6x minus 9 equal 6 times 3 minus 9, which is also 9. So yeah, the third condition, the f of 3 is equal to limit x approaches 3 from the left of right of f of x is equal 9. So yes, the function is continuous. So from the conditions, I can tell the function is continuous. So let's figure it out if it's differentiable. So for the differentiability, we have to find the limit x approaches 3 from the left of f prime x. So what is f prime x? F prime x is 2x, and plug in that 3. 2 times 3 is going to give me 6. Then we have limit x approaches 3 from the right of f prime x. F prime of that one is 6, so it's going to be a 6 anyway. So yes, limit from the left in right for the derivative is 6. So it is continuous and it is differentiable. So I'm going to say both continuous and differentiable. So the answer is B. Next question, if y equals sine square theta square plus 2, then dy d theta, which means what is the derivative? So since the square is on top of sine, I have to rewrite this, and it's going to give me theta square plus 2 as an argument, and the whole thing is squared. Now we take a derivative. It's a chain rule within a chain rule. We know that this inside is also chain rule, and that is also chain rule. So 2 jump to the front for y prime. 2 jump to the front, keep the inside as it is, theta square plus 2, and 2 subtract 1 is 1, times the derivative of inside. Now inside is again my chain rule. This is outside, that's inside. So outside derivative is cosine, keep the inside as it is, and the inside derivative is 2 theta. Now let's fix it around and we are done with the derivative. It's going to be y prime 2 times 2 is 4 theta. Then the rest of the stuff is going to stay like sine theta square plus 2 times cosine theta square plus 2. So for this, the answer is A. Question number 3, the function f is defined by this. If g is the inverse function of f and g2 is equal 0, what is the value of g prime 2? So what is this g? That's inverse. Okay, that's inverse function. Instead of f negative 1x, we're going to just write down g of x because they are the same. This is x, that's a y value. What is the value of g prime 2? Which means I'm looking for the derivative inverse, and we use a formula for this, which is equal 1 over g prime, f prime, actually, f prime, I have to erase that. Okay, now I'm going to have a formula which is 1 over f prime, and the inverse is gx, and that's what the formula is. Now let's go back and figure it out. What is gx? Gx, we have to look for g2. So what is g2? G2 means That's then x, and what is the y value? That's inverse function. So what is the original g function? If g is the inverse function of f and g2 is equal, okay, so that's inverse, which means that's a 0. So I'm gonna get this 1 over, I don't have to find 1 because they are already giving me inverse x and y's. So I got f prime 0. For g2 I plugged in 0 because that's what it was. Take the derivative of f, which is 3x squared f prime x, 3x squared plus 4, and plug in 0, so the answer is 4. So my answer is 1/4. Question number 4. It says if f of x is cosine 2x ln x 2x, then at which values of x, which means I'm looking for x is between 0 and 4, will the slope of the normal line drawn to the graph of f of x be half? So that's the slope of the normal line. Now you can see this is a function that I cannot change it to y equal mx plus b or anything. So you know, slope means a slope, and I have to take a derivative of this and make it this is just a normal f of x original. So when the normal line is given, then you can easily figure it out. I mean, if you guys remember, I said normal line and tangent line go back and forth. So if I take a derivative of this f prime x, this f of x, if I take a derivative, and then I'm going to make it equal the tangent slope, which is -2. That's my tangent slope. Make it equal -2, and I can find my axis very easily. It would be the same thing. Like they both, normal and tangent works together. So f prime x, I'm taking a derivative of that. That's negative sign. Outside derivative, inside keep it, times inside derivative, which is 2 minus ln 2x derivative is 1 over 2x. 2x is argument something. Like I said, derivative of something or times the derivative of that something is 2. So they cancel out. I'm left with 1 over x. So I don't have to do anything else. I'm going to make them equal to -2. Sine, I can make this 2 to the front, and sine 2x minus 1 over x equal -2. That -2, the tangent slope, and I took a derivative of that. That's a tangent. Make them equal each other, and then you graph them. But since it's a calculator-based question, I'm going to graph it. I'm going to graph the calculator, and according to the calculator, I have to move this around so I can see my equation. So I got -2 sine 2x, -2 sine 2x, then move the cursor. I have minus sign, and I have 1. I'm going to make a parentheses, and then I'm going to make 1 divide by x in parentheses close, and then hit enter. So that's my one graph. I have to have another graph, which is, I'm going to open another tab, and the other one is half. I mean -2, I'm sorry, -2. Then you enter. So I'm going to look for the point of intersections. But before I do this, my window is supposed to be 0 and 4. So I'm going to change my window to 0 and 4. So go to menu, window zoom, window settings, and I change this to 0 and change that one to 4. And okay. So my point of intersections are 2 right there. So how do I find intersections? Go to menu, analyze graph in intersection, move the cursor over here and move the cursor here. So my intersection is 1.249, one of them. Then if I'm going to redo this again because of the another intersection that I can see, click and click. The another one is 3.663 when you round it up. So my answers are 1.249, 3.663, which is A. That's how you find it. Question number 5. At which of the following values of x is gx defined? Gx is defined. Defined means when you plug in x, you should supposed to get some y value, So, and where is g prime is undefined. G prime, when the slope is, when it's not differentiable or it's undefined, you can say for the undefined, either making so many, at the x value, making so many tangent lines, or it's the vertical line, so it's undefined. So let's try -2. negative 2 is this. It's not defined because, you know, that's a g of x function. It's not defined. There is a hole. So I can't do that. We have to have these two conditions there. X equal 2. That's x equal 2. It is defined, which is a closed circle, and it is g prime is undefined because I can make a line like this, undefined. I can also make a line like that, a line like this, are tangent lines. So I'm making several tangent lines, so it's undefined. So it's x equal 2 and x equal 3. 3 it is defined, but you know it's a zero slope. So no, that's not it. So the answer is only D. We are not going to do question number 6 and then question number 7. They said if f of x is this, then what is the f prime x? I'm taking a derivative. This is f, that's a g. So it's a quotient rule. I can move the 2x to the top, make it negative 1, but it's going to be a product rule. Let's do the quotient rule. Quotient rule says keep the g as it is, then take the derivative minus keep f times g prime over g square. So I'm taking that. G is 2x, keep that, times the derivative of f, which is e2x times 2, you know, derivative of that, minus f stays e2x times the derivative of g, which is 2. In the bottom, 2x whole squared. So let's fix this around. I can do 2x, 2x times 2e2x minus 2e2x over 2x whole squared. So 2 times 2 is 4. So this is going to give me 4 x e2x minus 2e2x over 2x whole squared. Now I can tell e2x is my common factor. So I'm going to take out the common factor, 2e2x. I'm left with the 2x minus 1 over 2x whole squared. So question number 7, and where is, if we can see this answer somewhere, e2x, no, because I have 2e2x, or I can simplify that further because I don't have anywhere this 2, so I have to get rid of that 2. That's what it means. 2x minus 1 over, I got 4x squared, so I can cancel this with the 2. Yeah, there you go. So my answer is e2x, 2x minus 1 over 2x squared. Now, this is my answer right there. I mean, 2x. So it's B. That's how it looks. And remember, I stopped here. Then I was checking where I can find 2, and you can check in none of the answers has a 2. So it means they got rid of it, and I can only cancel it with the bottom. So that's how this one is. Free response questions. A tennis ball is mounted on a spring that is suspended from a ceiling in John's dorm room for entertainment, stress relief, boredom, or just for pure conversation piece. The tennis ball can be pulled down and released, and the ball will bounce up and down. The function below each t represents the height in feet that the tennis ball is from the floor at any given time t, measured in seconds after the ball is pulled down and released. Okay, so here's my function ht. Find the values of h1.9. It's h1.9 means that's an x value. You just plug it in the original and you will get the 1.9. And since we are using a calculator, that's what I'm going to do. h1.9, when you plug this 1.9 in the function, 3 cosine 1.25 pi, and for the t I'm plugging in 1.9 minus 0.5 and close. When I plug this in, so yeah, I'm getting 7.336. Plug this in the calculator exactly how it looks. So I got that. Then it says, then explain using correct units. I'm going to use the units and what each value represent in the context of the problem. Since we know this, time is 1.9 seconds and h is the height. So I have to get some words from there. So I'm going to say h 1.9 is equal 7.336 7.336 feet, because that's the height. You know, the height is in feet. T measured in seconds, and HD represent the height in feet. So that's why I have feet. That's the time in seconds. Which means, because they said context of the problem, which means that 1.9 seconds after the ball is pulled, and released, it will be height. This is the height. It will be so it will be height. It will be height of 7.336 feet above the floor. Okay, that's what it means. Now, next one, I'm saying h prime. Derivative first using this calculator. This is x. Cosine 1.25 pi and x minus 0.5 and enter. It gave me all of this when you take a derivative of it. Now, if I plug in x here for this, okay, let's highlight that and enter. Then for the x, I plug in, remove this, and I plug in 1.9, and then hit enter again. It gave me, there you go, it gave me negative 7.390. So that's the correct answer. And you guys noticed how I did it. I took a derivative, like a regular derivative on this calculator, and then after that I plugged in that x value, which is 1.9, and my answer is negative 7.390. And I don't know how why it doesn't work here. It's negative 7.390, which means rate of the rate of pulling and releasing the ball of pulling and releasing the ball. And that's in since this is and this is also in feet per second. This is rate is always per feet per second, like it has to have this per something. That one is just feet, that was just the height. But the rate means h prime is rate, it's a slope. Okay, for part B, in this question, it says t equal 3 is the ball ascending or descending. Give reason for your answer based on h prime t. So based on h prime t means I have to take a derivative of h and plug in that 3 there, and based on this we will decide if it's ascending or descending. Ascending means it's increasing, descending means it's decreasing. So every time one increase and decrease word comes, then it means I'm taking a first derivative and make it equal 0, critical points, and then we find sign chart. But if we plugged in 3 in the h prime, and then probably I will get positive or negative answer. Then we will decide if it's ascending or descending. So I'm going to take the derivative of h prime 3, and it's a calculator base, so I don't have to show them. I have to take a derivative and plug in 3 in the equation. Let's see what we get. So I'm going to go to my calculator again, And I'm going to use, this is actually my derivative that we got the first time. That's my function. That's the derivative. And for the derivative, for the x value, and if you highlight this, it's already on the calculator, then you enter, and then you would be able to change this x value when you hit enter and type. You don't have to type the whole thing again. Then I'm going to type in plus times 3, and it gave me the answer 11.304. So my answer is h prime 3 is 11.304. Give a reason for your answer. And since they are talking about seconds and height is feet, then I have to, my units are feet per second, and you know it's a derivative, it's a rate, so it has to be have a per. Now, this is my answer, and then they said give a reason for your answer based on this. I can say since h prime 3 is greater than 0, then the height, the ball is above the floor, is increasing, which means the ball is ascending, at t equal 3 seconds. Okay, done. Part C, find an equation for h prime t and sketch the graph of h prime t on the grid below for 0 to 4. So h prime t graph, I'm going to use my calculator, and this is my h prime t. I'm going to copy it. I don't have to write it again. I'm going to copy it. I go back, graph, and I paste it here. I think I don't know if I can do it. Let's try paste there. And then I'm going to hit enter. And this is the graph, but I have to change my window. My window has to be between 0 and 4. That's 0. This one has to be 4. And this is how the graph looks like. So this is exactly how I'm going to draw on my graph. So this is just a little bit 1, and this is all the way going to all the way down there. So I'm going to draw this like the way it looks. So I have to go back and check this. I'm going up all the way here. But here it's not going to work, but I mean, you guys can draw it nicely. There you go. That's my graph for the h prime t. Now, again, this side on the grid below, I can find an equation for this. So my equation for this, since we already know the equation for it, it's going to be h prime t. And on the calculator, I already have a h prime t, which I can go back to the calculate part, and it's this. This is my equation for, after I took a derivative of this function, this is what I got. So this is exactly what I'm going to write, negative 11.78, negative 11 point, or I can simply take a derivative of that. Okay, so my h function is right here, which I'm going to write first. My ht function is 5 plus 3 cosine, and inside is 1.25 pi t minus 0.5. I think I'm right. 5 plus 3 cosine 1. Yes. So this is my function. I'm taking a derivative. Derivative of 5 is going to be 0. The derivative coefficient 3 stays. Coefficient of 3 stays. This is outside and that's inside. So the outside derivative is negative. It's going to keep that negative here, sign. Inside, keep everything. Times the inside derivative, which is 1.25 pi. 25 and a pi. T, you know, invisible 1 times this is that, and this is what I got for the h prime t. So it gave me all of this. I can fix it around, like 3 times 1.25, I can get negative 1.375 pi, and then I have the rest of the stuff, sine 1.25 pi t minus 0.5, and that's it. That's my answer for h prime t. So that's done. D is on the interval 2, 3, at which of the t does the ball reach a relative minimum? When they talk about relative minimum, it means I'm taking a derivative, making equal 0, critical points, and then we make a sign chart. From the sign chart, if I'm going from negative to positive, that's where my relative minimum is going to be. With the reason your answer based on the h prime t and what height is the ball at this time. So this one on the interval, which I'm going to go back and check on the calculator. When we go to the graph portion, we already drew this graph. This was h prime t. I took a derivative, make it equal 0, find the critical points. All these are my critical points, these zeros where the graph is touching the x-axis. So these are my critical points. So where is my minimum? I can just simply go to menu. Since it's a calculator, so I'm not wasting time, I can go analyze and I find minimum. So minimum, they said the lower bound, like starting from 0 to upper bound all the way to 4. So my minimum is right here, which is 2.127. So this is my minimum at that point. Between, oh, they said between 2 and 3. I'm sorry, I didn't pay attention here. That's 2 and 3. So I have to make it between 2 and 3. So let's change the window one more time and make it between 2 and 3. So that's a 2. Make this 3 and enter. So now find minimum, which is right here, 2.127. So that's my minimum. So I can say on the interval, I can say on the intervals 2 to 3, it's t. I can say that 2 to 3, ht, because that's what they're saying, ht minimum, right? So ht is at minimum at t equal 2.527, because the graph of h prime t changes from negative to positive. Okay, what else they talk about? Give a reason for your answer, which I did. Based on the graph h prime t, at what height is the ball at this time? So now I have to figure it out, the height. So at t equal 2.527, we have to look for the height, and height I'm using the same formula, but I have to plug in 2.527, which was the time right there, and I'm going to plug it in the original to get that height. So it's going to give me 5 plus 3 cosine 1.25 pi, and the time is going to be 2.527 minus 0.5. When you plug this in the calculator for the original, I'm getting equal 2000, which is feet off the ground. Okay, so this is what it means. Since if this was not calculator based question, then technically I would take a derivative equals 0 critical point sign chart. Since this is a calculator, then I just h prime derivative you need a derivative of ht, which is h prime t, and it was already we took a derivative using a calculator and we graphed it. This was h prime graph right there. Question number 8, and these multiple choice questions are the calculator is not allowed. These are without calculators, so we are not going to use a calculator in here. They said f prime 0, this is my f function. I have to take a derivative of it and plug in 0. So the derivative of f of x function is ln, we know that ln x derivative is 1 over 1 over x times the derivative of x, which is 1. So in this case, that's what it is. Derivative of ln, whatever argument, whatever inside, or this is, I call this something. Like take the derivative of ln something, so 1 over something as it is, times the derivative of this something, which is 1 plus 0. Derivative of x is 1, derivative of 4 is 0. Derivative of e negative 3x is e negative 3x times the derivative of the top, which is negative 3. So this is what I got on the top. So let me plug in 0 there. I got 1 over 0 plus 4 plus e negative 3 times 0 times 1 plus e negative 3 times 0 times negative 3. So let's fix this around. F prime 0. This is e to the power 0 is 1. So 4 plus 1 is 1/5 times negative 3 times e negative 3 to the power 0 is e to the power 0, and then it's 1. So negative 3 times 1 is negative 3, plus 1 is negative 2. So I got negative 2 on the top up here. I don't have to write it up here. So negative 2/5, which is the answer for question number 8. That's C. Question number 9. The question is asking find the dy dx, which... Okay, for question number 9, if we check, we have a to the power 4. So that's a chain rule, and this is a quotient rule. Inside is quotient rule, but overall the question has a chain rule. So let's apply the chain rule first. This is outside and that's inside. So I'm going to go dy dx equal. I'm going to have 4 jump to the front, and I'm going to keep inside as it is, which is x cubed minus 2 over 2x to the power 5 minus 1. 4 subtract 1 is 3, times inside derivative, which is my quotient rule. According to quotient rule, this is f and that's a g. So g is going to stay as it is, 2x to the power 5 minus 1 brackets times the derivative of f, which is 3x squared, minus, then I'm going to have f as it is, x cubed minus 2, and times I have, and this times is going to distribute the negative. Then I have the derivative of g, which is 10x to the power 4, and done. All over bracket, and all over I have 2x to the power 5 minus 1 whole squared. Now let's fix this around. Or we don't have to fix it around because we have x equal 1. So all I'm going to do, plug in 1. I'm going to plug in 1 here. Let's not do here 4. And I'm going to plug in x minus 2, which is 1 minus 2. 1 cube is going to be 1 anyway, minus 1. 2 is going to negative 1. Over 2 times 1 is 1. 2 minus 1 is 1 again, and everything is cube. Times, now in here, let's multiply all of this. 2 times 1 is 1, minus 1 is 1, and 3 and 1 is 3. So this is going to give me just a 3. 3 times 1 is 3. Minus, and a bracket. This 1 minus 2 is negative 1, times 10 times 1 is 10. So it's going to give me 10 right there. And that's close, all over 2 minus 1 is 1. Okay, let's distribute that. 4 times a negative 3 is negative 4 times, and inside I have 3 plus 10 is going to give me 13. Multiply these together, it's going to give me negative 52. And that's what the answer is, D. Question number 10. If we check, up here we have a to the power x derivative, and the rule for the a to the power x was a can be any constant, like in this case our constant is 2, and on the top you have some exponent. The derivative is going to be like a to the power x, like a ex, times the derivative of x in times ln a. This is just one extra thing for here for this. So this is how the derivative of a to the power x means, and this is actually a product rule. So I'm going to apply a product rule. This is f, that's g. Overall question, when you look at it, that's a product rule, but actually this is also product and the a to the power x exponential derivative. So let's try that. We're going to take a derivative of h prime x, and we got to using product rule. Product means take the derivative of f, like f prime times g plus f times g prime. F derivative is 2x, keep the g as it is, cosine 2x, plus f, keep the f as it is, which is x squared, and derivative of g prime, which I'm going to do it like that. So derivative of g is times 2 cosine 2 x stays, times the derivative of that, which is going to be a chain rule. That's outside, that's inside. So negative sign, keep the inside as it is, times the derivative of inside, which is 2. I got that, times another times ln a. Right, I took a derivative of that. This is 2, exactly the same thing, times the derivative of x, which was exponent, and the exponent derivative, as you can tell, it's a trig. It has to be a chain rule. I did that outside, inside, times ln a. So ln a means ln 2. So I got everything done, and that's my product rule. So now let's see how we can plug in that 1 there. So I'm going to plug in 2 times 1, 2 no, it's supposed to go on the as an exponent, 2 cosine 2 times 1 plus 1 squared times 2 cosine 2 times 1 times negative sine 2 times 1 times 2 times ln 2. So I plugged in everywhere. When I see x, I plugged it in. 2 times 1 is going to give me 2. 2 times 2 to the power cosine 2 plus 1 times 2 is 2 cosine 2, and that negative is going to move up here, and I got sine 2, or times 2 sine 2 times ln 2. So let's try. This one, I can simplify it further since the bases are exactly the same. The exponent should add, so I'm going to have 1 plus cosine 2. Then this is minus, and this is also times. So technically, let's fix the 2 I don't have any other bases up here. So ln 2, sine 2, and I can make the 2 cosine 2 as a common factor. I can make that as a common factor. And it's a common factor. Then I'm left with, this is 1 minus ln 2 moved to the front, and this is going to be 2 sine 2. So this is what I got for the answer, and since that was I don't have a quotient, yeah, so that's my answer, and it looks like it's B. Next, question number 11. For 11, since this is a definition of derivative or limit process derivative. So there is a shortcut for it that I told you guys. Pick this. That's my f of x function. Tangent 3x. How do I know it's a definition or limit positive from h to approach 0 from this? So take a derivative of this. The derivative of this is going to be secant square. It's outside and inside. So outside derivative is secant square. Keep the inside 3x as it is, and 3x derivative is 3. So the answer is technically 3 secant square 3x. 3 secant square 3x. It's A. Question number 12 is a product rule again. If you guys check, that's a product rule. Multiply. So this is my f, that's a g. So derivative of f is 2x. If I'm taking a g prime x equal 2x, keep the other one as it is, plus x squared stays, and the derivative of ln, which is 1 over something, and the derivative of this is going to give me times the negative sine x. Now let's fix this. 2x ln cosine x minus x squared sine x over cosine x. Now sine x over cosine x is actually a tangent. So I'm gonna do that. Ln cosine x minus x squared in tangent x. Now x is my common factor. I'm gonna take it out. 2 stays, ln cosine x stays, minus x in tangent x. There, that's my answer, which is question number 12, which looks like to me C. There, that exactly like that. Question number 13. It says the piecewise function pictured to the right consists segment of linear function. Which of the following segments is or are true? F prime negative 4 is equal 1. F prime means that's the slope I'm looking. That's original. So I have to draw a tangent line at negative 4. 1, 2, 3, 4. That's a 4. The tangent line is right here. Since the tangent line is exactly parallel to this one, and I'm just going to pick this point and that point, and I find my slope. I'm rising 2 and running 1. So that's wrong. They said the slope is 1, but I'm rising 1, 2, and 1. So my slope is technically on this line is 2, but they said it's 1, so that's not true. F prime x is greater than 0 on the interval negative infinity to negative 3. That's negative infinity to 1, 2, 3, negative 3. Yes, it is greater than 0, because any tangent line up here from here to here, it's going to be positive. And then 1 and 2. So this is 1 and that's a 2. So 1 and 2 is this, so it's also positive. So all the lines are positive. That's true. F of x is continuous at x equal 1, but not differentiable at x equal 1. This is x equal 1, this is 1, and I know it's a cusp, so it's not differentiable, true, but it is continuous because no holes, no jumps or anything. So that's true. So my answer is D. Okay. Question number 14. In question number 14, the question is asking if hx is equal square root f of x and f3 is equal 10, which means that's x, that's a y value, then f prime 3 is equal 4, which is 4 is a slope at x equal 3. What is the tangent slope? The h prime 3 means the tangent slope at x equal 3. So I have to take a derivative of h of x. I have to rewrite the hx first because I have that square root, and we always rewrite the square root. Take a derivative. It's a chain rule. Half jump to the front, keep the f of x inside as it is, and half subtract 1 is negative half times f inside derivative, which is f prime x. Then I have to rewrite this. So 2, it's going to go f of x square root, and the f prime x goes on the top. Now I have to plug in everything. Everywhere I see x, I have to plug in 3. So I got h prime 3 equal f prime 3 over 2f3. Now plug in the values that is given. F prime 3 is 4, 2 stays here, and square root f3 is 10. you can simplify this, and that's gonna give me 2 over square root 10, and the answer is B. Let's do the free response questions. No calculator like they said. So I'm not using a calculator. This is a piecewise function where k and p are constants. If k is 3, p is -3, is f of x continuous? Is f of x continuous, which means 3 conditions I have to give them at x equal 1. The first condition is f of 1 is defined. F of 1 is defined. If I plug in 1 here, and I'm going to plug in 1 only in this piece of information, this piece of function, because this is only one says equal. So if I plug in 2x minus x squared, this is going to give me 1. So yes, it is defined. Condition number 2, limit x approaches 1 from the left of f of x. So which one is left of f of x? Left is that one, which is 2. Plug in 1 minus 1 squared. It's going to give me 1 again. Then I have limit x approaches 1 from the right of f of x. The right portion is I'm using that one. And since they're already giving me the k and p value, so I'm going to plug in that plus 3x minus 3 for p. And when we plug in that 1 here, I'm getting 1 square plus 3 times 1 minus 3. They cancel out and I'm left with 1 again. So yes, 3 conditions. I'm meeting all the 3 conditions. The third condition says f of 1 supposed to be equal limit x approaches 1 from left and right of f of x, both of them equal 1. So it means the function is continuous. Therefore, f of x is continuous at x equal 1. Part B. The part B is asking if the k is 3, -3 is differentiable using your limits. So differentiability, if you guys remember, it was limit x approaches 1 from the left of f prime x, and then it's supposed to be equal limit x approaches 1 from the right of f prime x. So I have to take a derivative of the left first. So let's look at the left one. Left is this one, that's the left. So take a derivative of that. I'm going to get 2 minus 2x. That's a derivative. Take a derivative of this one, which is going to give me 2x plus 3. Now we make them equal each other and plug in 1. So if I plug in 1 here, 2 minus 2 and 1 equal to 1 plus 3. This is going to give me 0 and this is going to give me 5, which means the does not exist because the limit from left and right are not the same. So I can say limit x approaches 1 f prime x does not exist because limit x approaches 1 from the left of f prime x is not equal limit x approaches 1 from the right of f prime x. That's why it's not. I justified and I said that all of that stuff. So it means is not equal that. Therefore, f of x is not differentiable at x equal 1. Okay, for part C, I'm going to use continuity and differentiability to find the k and p. For continuity, we already know limit x approaches 1 from the left. Limit x approaches 1 from the left is 2x minus x squared, 2x minus x squared, and equal limit x approaches 1 from the right, which was x squared plus kx, x squared plus kx plus p. That's continuity. So I have to plug in all of these values. So I'm going to write limit x approaches 1 from the left, and I'm going to plug in, or probably we shouldn't be writing this over and over. Okay, let's try that. So I'm going to plug in 1 here. It's going to give me 2 minus 1 is 1. In this case, when I plug in 1, it's going to give me 1 plus k and plus p. Subtract 1, subtract 1, it's going to give me 0. So k plus p is equal 0. Now let's do the differentiability. Limit x approaches 1 from the left, and I'm going to take a derivative of that, like f prime x will give me 2 minus 2x. Then limit x approaches 1 from the right of f prime x. That's a differentiability portion, okay? And this is continuity. I didn't give them 3 conditions because I already gave them on the top for part A. So this is what it is, f prime x. And since this is just one question, like all these A, B, C parts are together, so they can see that I already found the continuity right there. So f prime from the right is going to give me 2x plus k. So these are my values, and I have to make them equal each other. So 2 minus 2x equal 2x plus k. Plug in 1 here. So 2 minus 2 is going to give me 0, and 2 plus k right here. So I got system of equation up here, and I have to figure it out how to find. So I got 0, 2 plus k, and I got 0, k plus p. I'm just writing k under the k. Then multiply this one, or maybe this one, with negative. So it's going to give me 0 equal negative 2 minus k. So k and k cancel out, and I'm left with 0 equal p minus 2. So I'll add 2 both sides. It's going to give me p equal positive 2. So if I get positive 2, I have to plug in somewhere, either in this equation or maybe in this equation, and I'll get k. When I plug in p here, I got 0 equal k plus 2, and you subtract 2 both sides, it's going to give me negative 2 equal k. So my k is negative 2, my p is positive 2. If you guys have any questions, please let me know.